Looks like you're on to the product rule, quotient rule, and chain rule.
Mm-hmm.
Which page do you want to start with here?
Just whichever one. I have no preference.
Okay. This work? This really doesn't have any problems on it.
Yeah, I know. I was just wondering if you could go over it with me, like rather than just like
Yes, be happy to.
get.
One moment. Takes a while for this thing to come up. And even when it does, it's slow. There we go. All right. Let's say I have y equals u. Okay? And u is a function of x. So it's really y equal u of x. If I were to take dy dx, I don't see any x's over on the other side. The best I can do is take dy du, and then if I multiply that by du dx, look what you end up with. Treat it just like fractions. They're not fractions, but you can most of the time treat differentials as if they're fractions. In other words, that goes away, you end up with dy dx.
Mm-hmm.
Okay? Now, the simple rule that they give you when applying the chain rule is the derivative of the outside times the derivative of the inside. Okay, so if I say x squared plus 1 to the 1/2, then what's u? U is the inside. What is the inside? What do you think the inside is?
X squared plus 1.
It's usually the obvious, okay? So now we have y equals u to the 1/2. Well, if I want to differentiate that, if I want dy dx, then it's 1/2 u to the minus 1/2. You with me?
Mm-hmm.
But then what's du dx? Because I still got to multiply it by du dx. Well, what is du dx over here?
X squared plus 1 over.
Just take the derivative. What's u prime? Real simple. Use the power rule.
So it'd just be x. No, 2x.
That's it. 2x. So I've got to multiply this by 2x. In other words, this was dy du, and this was du dx. Now I go back in and I substitute back for u. In other words, you don't usually have to make this u substitution, but u is x squared plus 1, still to the negative 1/2, and it's still multiplied by dx. Okay, so if we look at this a slightly different way, in other words, this is the way they teach you, but you don't really need to know this. Is all you need to do is follow the simple rule, the derivative of the outside times the derivative of the inside. Okay, so in this problem here, I don't need this over here. I'm going to erase it. And I don't need that. And I don't need any of this. What's the derivative of the outside? Just use the power rule. Treat this as the inside and take the derivative of the outside using the power rule.
Would it just be 1/2 x squared plus 1 negative to the negative 1/2 power?
That's the derivative of the outside. Now what's the derivative of the inside?
2x.
Same exact thing, only I didn't really have to use U substitution. The only reason they show you that U substitution is because it's the rationale behind the rule, the derivative of the outside times the derivative of the inside. Okay? Now, most of the time, it's going to be pretty obvious what the inside is. Not always. I'm going to give you a couple that might be a little tough. It's the outside. What's the derivative of that? Knowing you have to use the chain rule.
So,
what's the derivative of the outside? Well, no. Actually, the first question you have to ask yourself, what's the inside?
5x?
Yes. Okay, now what's the derivative of the outside?
Just be 1?
What's the derivative of sine?
I don't know.
They haven't taught you the derivative of trig functions yet?
No.
Okay. Well, it's cosine. So there's the derivative of the outside. What's the derivative of the inside?
5.
Exactly. Okay? So that's how the chain rule works. And am I correct that they have taught you the product rule and the quotient rule?
No, they haven't.
Truly? They're teaching you the chain rule first.
No, I don't know what order it is in, to be completely honest. We just, I know that these are the next 3 subjects we're going over.
All right. Well, let's go back and look at your paperwork. I think that's going to be our best bet here. I could go in, and there's no problems on here. But notice that's what they say here. dy dx is dy du times du dx. Well, dy du is the derivative of the outside. Du dx is the derivative of the inside. And this stuff over here, don't even worry about that. That's just going to confuse anybody. All right. We don't need this page anymore. I'll get rid of this question. All right, here we got some problems. Take a snapshot of it. All right, so on number A, give me the derivative of the outside.
Would it just be 3 in front and then 2 to the second power?
You don't change the inside. When you're taking the derivative of the outside, just do the derivative of the outside. So that's 5x plus 4 to what power?
Second.
Okay. Now what's the derivative of the inside?
5. Just 5.
Just 5. And there's your answer. Now you can multiply 3 times 5, so you get 15. But that's your answer. They have given you trig functions. Let's talk about derivatives of trig functions. I can help you a lot. Hold on a minute. Man, I got to figure out a different way to do this. All right. And I'm going to teach you a slightly different way to do these. Starting with sine x. That's the function. Here over here is the derivative. The derivative of sine x is cosine x. You got to memorize that one. No way around it. Now, the next one they usually teach is cosine x, but I'm not going to teach it like that because it's not the best way to teach it. This is. The derivative of tan x is secant squared of x. And finally, the derivative of secant x is secant x tan x. Okay? Those three you got to memorize. No way around it. The other three you can figure out from these three. In other words, cosine x is to sine x. It's the cofunction of sine x. Do you know cofunctions? Cofunction is take the trig function and stick a co in front of it, and unless it already has a co in front of it, and then take it off. That's cofunctions. So cosine is cofunction with sine. Sine is cofunction with cosine. What's the cofunction of tangent?
Cofunction tangent?
Stick a co in front of it. You understand cofunctions? What's the cofunction of secant?
Cosecant.
Good. Now, the derivative of sine was cosine. Well, the derivative of all of your cofunctions is first of all negative. Second of all, it's the cofunction of that. So that's what the derivative of cosine is. Now you tell me what the derivative of cotangent is going to be.
Negative tangent.
Negative. What's the cofunction of secant? Cosecant.
Yeah.
Notice the pattern. In other words, this is the cofunction of that, and that is the cofunction of that, only with a negative sign. So now tell me what the derivative of cosecant x is. See if you can pick up the pattern here.
Negative secant.
No? What's the derivative of secant?
Cosecant.
What's the cofunction of secant?
Cosecant.
What's the cofunction of tangent?
Cotangent.
Now, do you see how you can figure out all of the ones that start with C from if you have 1, 2, and 3 memorized? You see the pattern, first of all? You do have to memorize the derivative of 1, 2, and 3. I don't know of any logical way to memorize that other than just memorize it. Okay? But the second ones, 4, 5, and 6. 1 second, Jacob.
Okay.
Hello? Yeah, when can you come out, Kenny? Yes. It went out after I ran it 3 times. I'm in a meeting right now, so if you could be quick, when would you like to come out? Okay. That's what happened, is all the lights went out. It didn't drain. It didn't drain the previous cycle, and all the lights went out. Now I can't get it to do anything. Okay. Thank you. Bye-bye. I apologize.
That's fine.
I've been trying to get my dishwasher fixed for a month. So I didn't want to ignore any calls. Okay.
That's a long time.
So I'm going to go test you here. First of all, do you have one memorized?
Yeah.
You have two memorized.
Maybe.
Tangent is secant squared. It's a little unusual, but that's the derivative of tangent, secant squared.
Mm-hmm.
And then secant is also a little unusual. The derivative of secant is secant times tangent.
Mm-hmm.
Okay. So, he's doing erase really good. Let me go to a new page. And you got to memorize these because I can see on your paperwork that they do expect you to know trig functions. So let's start at the top. Give me the derivative of sine x.
Cosine of x.
Give me the derivative of cosine x.
Negative sine x.
Good. Give me the derivative of tan x.
The secant x.
Secant squared.
Okay.
Now that should allow you to figure out the derivative of cotangent x.
Cosecant squared.
Remember, all of the cos start with a negative sign, always. All three cofunctions, their derivatives begin with a negative sign.
Okay.
And what's the rest of it?
Negative cosecant squared of x.
You got it. And finally, secant of x.
I don't know.
Secant tangent. This is probably the hardest one to memorize. I'm not sure why, but it is. But now the last one should be easy. It's cosecant.
Cosecant x. Oh, no. Negative cosecant x. Cotangent x.
Got it. You got the pattern down. So you can see the only ones you have to remember are that one, and that one, and then just use the system on the other three. Oddly enough, they teach these in kind of a strange way. They teach these two first. And unfortunately, that doesn't really teach the person the system that they're looking at. It just teaches them the derivative of sine is cosine and the derivative of cosine is minus sine, and they end up forgetting that half the time. So this other way to teach it is, to me, unquestionably better. Teach sine, tangent, and secant, and those are the only three you have to memorize. The other three you can figure out. Okay?
Okay.
All right, let's go back and look at B and C. Take a picture of it. Now, these are actually distinguishing between these two. If you can figure this out, you got it made. Because these two represent really the hardest problem about the chain rule, which is figuring out what is the inside. Let's start with C. It's a little easier. What's the inside?
X cubed.
Good. So if I had to use U, okay, now give me the derivative of, tell me what y prime is.
It would be 3 sine x squared.
Oh, what's the derivative of the outside? In other words, what's the derivative of sine of U? Yeah, exactly. Cosine of U, which is x cubed. So there's the derivative of the outside. What's the derivative of the inside?
3x squared.
Perfect. Okay? So that one's easy. The inside is pretty clearly x cubed. Now let's look at B. What's the inside on B?
Just x?
No, there's got to be an inside. The inside is, and here's how you figure it out. I'm going to let the inside be that. And then the problem becomes u cubed, right? In other words, the difference between B and C, B means the sine of x times the sine of x times the sine of x. C means you cube x first and then you take the sine of it. So B and C are not the same by any means. And this actually illustrates the chain rule the best possible way, because it's not so easy to figure out the inside. It is on A. Clearly the inside on A is 5x plus 4. If you cannot figure out the inside, do it this way. Go through u substitution, and then you would have y equals u cubed. Well, you can take the derivative of that. It's y equal 3u squared, derivative of the outside, times derivative of the inside. If you know that it's sine x, then cosine x. Now go back and substitute for u, and you get 3 sine squared x cosine x. Now, we didn't really need the u. We didn't need to do it like that. The only reason I did it like that was to clarify it for you. If I go straight to this step, there's the derivative of the outside, correct?
Mm-hmm.
Start with the exponent, subtract 1 from the exponent. That's the outside derivative. And the inside, since it's sine x, that's the derivative of the inside. And that's your answer.
All right.
Okay. All right. Let's see what else we got on this page here. These are really kind of easy until you get to C. Let's just go through some of these for practice. Let's do A. What's the derivative of the outside?
9.
Now, always start with the exponent. Don't subtract 1 first. Start with the exponent.
Oh yeah, so it'd be 10.
Okay.
And then the 9th power on the outside.
Well, let's put everything else inside there. In other words, I want to make sure you don't change the inside when you take the derivative of the outside. That's the derivative of the outside, correct?
Mm-hmm.
What's the derivative of the inside?
That would be 18x squared plus 3.
That's it. There's your answer. Okay. Now, let's look at number B. First of all, how should I write that? Remember, radical signs don't work real well.
Just put it to the half power instead of a radical.
So it's really y equal 5x squared plus 1 to the 1/2. Now differentiate that. Derivative of the outside? First of all, I'm going to ask this every time. What's the inside?
5x squared plus 1.
Okay. What's the derivative of the outside?
1/2 5x squared plus 1 negative 1/2.
Now what's the derivative of the inside?
10x That's it.
That's it. There you go. Now, C. This indicates that you've had the quotient rule also. So real quickly, I want to go through the product rule and the quotient rule with you. There's only 4 rules. There's the power rule, the product rule, the quotient rule, and the chain rule. Sometimes you have to use them in combination, okay? We're looking at a quotient there. So we're probably going to have to use the quotient rule. And we're looking at that whole thing to a power, so we're probably also going to have to use the chain rule. So what we really need to go over is all of them. The product rule is the simplest. Okay? If I have, and this is usually stated like this. Okay? U times V really could be stated as U as a function of X and V as a function of X, like that. I don't need this second set of parentheses here. In other words, you have 2 functions that are multiplied together. Each one is a function of X, and you can't actually multiply them together. An example might be X sine X. Okay? I can't multiply those together. That's as much as I can simplify, X sine X. But what it is, U of X is X, V of X is sine X. They're both functions of X. Therefore, I can use the product rule. Now, here's what the product rule says. It's really rather straightforward and simple. The derivative is the first function times the derivative of the second function plus the reverse. What's the reverse of that? When I say reverse, this is what I mean. U prime times V. You see why that's the reverse?
Isn't that the same? Oh, wait. Okay.
In other words, when you do the product rule, you take one function times the derivative of the other plus the derivative of the first function times the other function. In other words, this is the reverse of that, correct?
Mm-hmm.
And because you're adding them, you can do it in whatever order you want. All you have to remember is you take one function times the derivative of the next plus the derivative of the first function times the second function. Okay, now let's try it on this function x times sine x. Now, I'm going to recommend something that not everybody recommends, but I think it's always the way to go. Even though the associative property holds when you're using the product rule, and you can do them in either order, I recommend always doing them in the same order. In other words, always do U times V prime plus U prime times V. Always do them that way. You could switch them up, but that'll just make it confusing and harder to memorize. So let's always use this. So if that's our 2 functions multiplied, what is the derivative? We're going to call this y. What's y prime?
So the outside would be x sine, right?
This is not the chain rule. This is the product rule. Different rule.
Okay, so what would you classify as u and v then? Because I'm kind of confused on that.
U is x, v is sine x.
Okay, so you take
I have pointed arrows there. U of x is x, v of x is sine x. 2 different functions, which we can no longer combine any further. So what's the derivative based on this rule?
So the first one would be x cosine.
X, okay.
And then plus just sine of x.
Good. 1 times sine of x. That's how the product rule works. Okay, let me give you another one. Notice I cannot combine those. That's as much as I can simplify it. I cannot multiply x times the square root of x plus 1. I can't rewrite it. Let's rewrite it without the radical sign.
Okay, so it would be x and then in parentheses x plus 1 to the half power.
All right. Now, there's u, there's v. Tell me what y prime is.
Y prime.
Do it step by step. Don't worry about the order that you're writing stuff. We can always rearrange the order that we write it to make it prettier.
Okay, so it would be 1.
No,
so just
always start with that, x. Don't, I know you can do it either way. That will just confuse you. If you always start with the first function, you're going to be better off. Now take the derivative of v. That's v.
1/2 x plus 1 to the negative 1/2.
Good. Now what's the rest of it? In other words, that's just the first part. That's u, v prime.
And then the next one would just be x plus 1 to the 1/2.
Correct. And that's your answer. Now, when you use the product rule, these things get complicated fast, as you can see. We had a relatively simple thing, and it turned into a pretty complicated thing. Nonetheless, that's the answer. Okay? Now, you could take this 1/2 and put it in front of the x if you like. Makes it a little more traditional. But the rest of it is the way you'd want it. So that's the product rule. Now we need to teach you the quotient rule, because in order to answer question C, we need the quotient rule. In fact, C is a bear, a real bear. Here's the quotient rule. If I have y equal to one function divided by another function, which is what that is, forget the 3 for a moment. The numerator is u. That's 5t squared. The denominator is 3t squared plus 2. At some point, in order to take the derivative of that, we're going to have to know that. Okay? But first of all, this one's a little tougher to memorize. But I have a really easy way to memorize this. Start with the bottom, end with the bottom squared. That's all you got to memorize. Start with the bottom. Well, I know it's going to be multiplied by something. It must be the derivative of the top. And this time it's subtraction. It's not addition, which means order matters very much here. I can't switch these two. So the other side is the reverse of this. So the other side's got to be v prime u. Okay, you see how that's the reverse?
Yep.
Divide by the bottom squared. Simple as that. In other words, as long as you get that part right and this part right, you're getting everything else right. If you start with the bottom, the next term's got to be the derivative of the top. There's nothing else for it to be. And I know order matters, so I know it's subtraction, not addition. And then this part is just the reverse of the first part.
Okay.
So let's ignore this 3 for a moment. Let's apply the quotient rule to that function, because I cannot reduce that. Notice, I can't divide both sides by t squared. I can't do anything. I can only use the quotient rule to solve that. So let's do it. Start with the bottom.
Okay, so the bottom would be 3t squared plus 2.
Yeah, put it in parentheses. Multiply it by the derivative of the top.
So that would be 10t.
Subtract. Now what's v squared? The top, or the derivative of the bottom.
That would be 6t.
And finally, the top.
5t squared.
And the whole thing is divided by what?
3t squared plus 2 in parentheses squared.
That's the way you do the quotient rule. Now, the only reason this is the hardest one to remember is because the subtraction makes the order of the numerator important. I cannot switch these. I cannot start with the derivative of the bottom times the top. I've got to start with the bottom times the derivative of the top. So if I'm trying to memorize that, notice that if I just remember, start with the bottom and end with the bottom squared. That's it. I got it.
Cool.
I'm going to give you another one. Think for a second here. Be a good one to give you. Yeah, we'll give you a simple one. Again, I can't really simplify that. It'd be one thing if I had everything over x squared, then I could separate it into 2 fractions and use the power rule only. In other words, if I had the reverse of this, let's assume, I'm just going to mix it up here for a second, probably a mistake because I don't want to. If I had that, okay, notice that I can turn that into that fraction, which is x to the minus 1, plus this fraction, which is x to the minus 3. And now, what's the derivative of that? I don't need a quotient rule. What's the derivative of x to the minus 1 plus x to the minus 3?
Negative 1x to the negative 2 power, and then plus negative 3x to the negative 4th power.
That's the answer. In other words, I was able to use nothing but the power rule because I didn't have to treat this as a quotient. I was able to break it up into 2 fractions. Okay? But if I reverse it, and I make y equal x cubed over x squared plus 1, I cannot make that 1 and add that. You cannot do that. It's only a plus b over c can be broken up into 2 fractions, but a over b plus c cannot. So for this problem, I've got to use the quotient rule. Tell me what the quotient rule, how it goes.
Okay, so it's
what are the most important parts to remember? So that you never forget. Start.
The bottom's v squared.
Start with the bottom and end with the bottom squared. That's all you have to do, is memorize that. Start with the bottom and end with the bottom squared. Well,
okay.
Starting with the bottom, what am I starting with?
So it'd just be x squared plus 1.
Times what?
3x.
Squared. In other words, I'm taking the derivative of the top. If I start with the bottom, then it has to be multiplied by the derivative of the top. Okay, now this is going to be the reverse of that.
So it would be 2x times x cubed.
Perfect. Now divided by what?
X squared plus 1 squared.
Great. And you don't need to expand that. Okay, you just don't. Now, when you use the quotient rule, a lot of times there is some very sophisticated algebra to be done. In other words, I can definitely combine those two terms, so that becomes minus 2x to the fourth. And I can combine these two terms, and notice what that turns into. It turns into 3x to the fourth minus 3x squared. Well, now I can combine that with that. So I actually end up in the numerator with x to the fourth, one of them, minus 3x squared. So that's what my numerator turns out to be with just a little bit of algebra. Down here, I've still got x squared plus 1 squared. Now, I'm not going to give up on this yet. Can that be simplified? That's always the hard part when using the quotient rule. It's not plugging it into the quotient rule. It's the algebra. What can you factor out of the top?
X squared.
Leaving?
X squared minus 3.
Unfortunate that that wasn't x squared plus 1. Because then I could have done some heavy-duty cancellation. Well, I can't. I cannot cancel x squared minus 3 with x squared plus 1 in any way, shape, or form. So that's my final answer. But you don't always know, and I didn't actually need to factor. In other words, that could have also been my final answer. If this was a multiple choice test, this one would probably be the one that was on there.
Okay.
In other words, you only factor if it helps. Let's say I'd have factored it and I'd have gotten an x squared plus 1. Well, now I can cross that out with one of those, and now I've simplified it down to x squared over x squared plus 1. So there's always lots of extremely tough algebra to do to simplify the derivatives after you've used the quotient rule. And Lord help you if you have to use the quotient rule twice. In other words, if you have to do the second derivative. Because imagine if that's the first derivative, and now they say, what's the derivative of that? It just gets more and more complicated. And I mean, seriously goes up in degree of complicatedness. You're still just plugging in everything, but then simplifying it is what becomes tough. All right, now we're ready to tackle C. C, we have to apply the chain rule. What's the derivative? What's the inside of C?
5t squared over 3t squared plus 2.
What's the derivative of the outside?
Just cubed. All that's a cubed.
Not cubed. In other words, I start by the 3.
Oh, yeah, no. 3 and then all of that in the parentheses.
Squared.
Yes.
And that's just the derivative of the outside. Now I got to apply the chain rule and find the derivative of the inside. Well, we just did that. You remember what it was? I think it was x to the fourth minus 3x squared all over x squared plus 1 squared. In other words, this is the derivative of the inside using the quotient rule. And so the whole thing, this is the answer. And I've used x's here. These are actually t's, not x's. In other words, you don't have to always be in x, but you have to use the same variable. The variable is t here. So what I'm finding is not dy dx, I'm finding dy dt. Okay?
Okay.
So whatever the variable is, that's what you're finding the derivative with respect to. And this is why dy dt is better notation than y prime. Notice that these all mean the same thing. Dy dx means the same thing as f prime of x, means the same thing as y prime, means the same thing as delta y over delta x, although you don't usually see that fourth one. But those all mean the same thing, but they have different levels of power. That does not tell you what you're differentiating with respect to. It doesn't say you're differentiating with respect to x or t or r. It doesn't tell you the variable. This does. This is the most robust of all, because once you find the derivative function, now you could say, okay, what's f prime of 2? In other words, you could calculate the slope when x is equal to 2. So the least robust is that one, but that's the shortest to write. So an awful lot of people use that one, y prime, even though it doesn't tell you the variable. So you have to know that this y prime means dy dt. Always has to, the denominator has to be this variable. All right. All right, that takes care of that page. And a lot of others, because I covered the product rule and the chain rule.
Mm-hmm.
This page here? Yeah. No, that was the page we just covered. All right. Combining rules. That last question was also combining rules. They just didn't put it in there. I don't know why. And why is this not working? Hold on. There it is. All right. So first thing we see here, let's rewrite it without the radical sign. And this is another way to write it. In other words, I'm taking the derivative of that function with respect to x. But let's write that function properly. X squared times what?
In parentheses, x squared plus 1 to the half power.
Okay, now let's start applying, always start with the product rule. So this is u, this is v.
Okay, so it would be u prime v, right? Or u.
Always start with the first thing you see, straight out. Always start with u. And then do v prime. And then add u prime times v.
Okay, so it'd be 2x.
No, always start with what you see, x squared. Start with u. That's u. Don't start with u prime.
Okay, okay.
Always start with u. Okay?
Okay.
Now what's v prime?
It would be 1/2 x squared plus 1 minus 1/2 to the power.
Now, that's not really v prime. V prime requires the chain rule. Because all you did was just take the derivative of v. What's the derivative of the inside?
It would be just 2x.
So that's u v prime. That's u. this whole thing is v prime. Okay? So that's all we've done so far, is done u v prime. Now let's do the rest of it. Plus, now do the reverse.
Okay, so it would be plus 2x times x squared plus 1 to the half power.
There's your answer. That's the answer. Now there are some perhaps simplifications I can do to that, but I really don't want to get you into the simplification part yet, just because that's actually the hardest part. The power rule is easy, the product rule is easy, the quotient rule is easy, and ultimately you'll get to the point where the chain rule is easy. And combining all four rules isn't hard. But sometimes the algebra is pretty hard. You're going to do stuff like factor out things like that. Notice that I have an expression where I could actually factor out x squared plus 1 to the minus 1/2 and perhaps simplify it. Not so important when you have the product rule because I'm not dividing by anything. So I'm probably not going to be able to simplify that. In fact, the best simplification I can do is cross off that 1/2 with the 2. And I'd probably leave it like this. In other words, I would leave this as my answer. Let's not worry about simplifying it. First of all, it can't really be simplified. As I look at it, there's no simplifying that. Sometimes there is, but this one you can't. Usually the simplification that requires the really hard algebra is when you're using the quotient rule, because you have a denominator. And frequently, both terms in the numerator have the term that's in the denominator. Notice that if I was dividing by x squared plus 1 squared, now my numerator has an x squared plus 1 and both pieces of it. My denominator has an x squared plus 1. I'm going to be able to factor out that x squared plus 1 and cancel it with a piece of the bottom. So if I had the quotient rule, then the algebra becomes far more important. But at this point, let's not worry about the algebra, although that truly is the hardest part of these, in my opinion.
Okay.
Anything at the bottom down here? No. So let's go look at this last page here. We got 5 or 10 minutes. Why is this giving me problems? How come I had to click on that 5 times to get it to work? Oh boy, implicit differentiation. Okay. We'll touch upon this. Implicit differentiation, no, yeah, I guess we're going to have to. Okay. I'm going to give you this one separately on my pink. It's a lot of subjects to cover in one session. We're covering the product rule, the quotient rule, the chain rule, and implicit differentiation. If I have an equation that is not solved for y, like that, that's the equation of a circle, and I want to differentiate that, well, calculus is just like algebra. Whatever I do to the left side, as long as I do it to the right side, I'm fine. So the left side, I'm going to differentiate that with respect to x, and the right side, I'm going to differentiate that with respect to x. Okay? Now, here's how you do it. You do it just like normal differentiation, unless you come across a variable that's different than that one, which y is. So what's the derivative of x squared?
2x.
What's the derivative of y squared?
2y.
But because y is not x, I have to follow this with a dy dx. Just the rules. When you're doing implicit differentiation, if you run into a variable that is not the variable of your denominator, you have to follow it with a d of that variable dx. The right side becomes 0. The derivative of any constant is 0. And now you can figure out, well, we've solved for dy dx. dy dx is going to be minus x divided by y. There's your derivative. And notice one very key thing. Your answer is not just a function of x. It's got x and y in it, which is very, very common and very, very okay. In other words, if I had a circle and I want the slope at any point, let's say, what's the slope right there at 3, minus 2? Well, plug in 3 for x, plug in minus 2 for y, and that says that y prime, or dy dx, is minus 3 over minus 2, or plus 3 halves. That's the slope of that tangent line, 3 halves. And we did not have to solve that original equation for y, which we could have done and used explicit differentiation, but sometimes that gets particularly hard. Let me give you just a quick example. In this example, I actually could have solved it for y. But how about if I had something like this? I can't solve that for y. You can't either. So that's not really an option with this. This may or may not be a function, but derivatives apply to relations, not just functions. In other words, if you're using implicit differentiation, then you can apply it to functions or relations. This relation might not be a function, but if I take the derivative of it, I'll be able to tell the slope of the tangent line no matter where it is. So let's take the derivative of this with respect to x. What's this term here? This might be a little complicated. We're covering a ton of material today, but if we can do it, let's do it. Here, I'll work you through it. That's 2x. I do not need to follow that with a dx dx, because that's
okay.
Okay.
Then 2.
On this, we got to use the product rule. So start with 2x. That's u.
Plus.
Not plus.
Times.
What's the derivative of y?
Just 1.
1 times dy dx. Because it's y, which is a different variable than x, I have to follow that with that. And I didn't mean to put a parenthesis there because we're not done with the product rule. What's the rest of the product rule? Now, take the derivative of u.
It would be just 2
times y. Now, I didn't have to follow that y with a dy dx because I didn't take the derivative of y. I was only taking the derivative of that for that second part. And then I'm multiplying it by the other function, which is just y. So it's only when you take the derivative of a different variable that you have to follow it with a dy dx. Okay, now we're on to this term. What's that?
Plus 2y times dy over dx.
Perfect. Equals 0. Now, notice that what we have here is I got two different dx's here. So the way to solve this problem is to gather every term with a dy dx in it on one side, and take everything else and put it on the other side. With me?
Mm-hmm.
Now factor out the dy dx. So you only have one of them. So you end up with dy dx times 2x plus 2y, that's the left side of the equation, equals the right side of the equation. Now I'm going to divide both sides by that and get 2x plus 2y. Can divide top and bottom by 2. There's your derivative. That's what dy dx is.
Okay.
Okay? And I used implicit differentiation, plus I had to apply the product rule, and then I also had to factor. The factoring is the tough part. It's this step here to get from there to there that most people have trouble with. In other words, once you get it laid out, you still have hard algebra to do. And algebra is you combine like terms. The only like terms I see are a dy dx, which is what I'm trying to solve for. So I can do it. All right. Looks like we're going to have lots of time this week to cover all three of these things.
Okay.
I hope we do. We need at least another session to go back over and cover the power, product, quotient, chain rule, and implicit differentiation.
Okay.
All five of those are extremely important. I would hope that we wouldn't try to cover all of them in just one session.
Okay.
Okay? Jay,
all right, well,
your session tomorrow, I think, is at 3.
All right, cool. Well, I'll see you later.
Talk to you tomorrow. Bye-bye.